So now we'll look into the simulation part of our code. As you can see, I've already loaded our code, which is here, and I've already applied the breakpoints at the point at the place where I want to see the change of state. And now we'll click on project and build to see if it's built successfully or not. So we'll go ahead and click on build. As you can see, it came up as built successfully. Now we can close this window, and now to check the simulation we should go to debugger. Now we should select MPLAB sim. Now we can watch what's going on in the code, so you should go to view and watch. Now the thing that we are interested in is number of bits, number of switches we have used, so that one. So we click on S symbol. So the switches we've used is RB0, RB1, and RB3. And we're also interested in seeing the state number changing, so edit the state number as well. And now we'll go to debugger, stimulus, open new workbook. Now select the switches we have used in our code, which is RB0. We'll make it a toggle switch. RB1, which is a toggle switch as well, and RB3, which is a toggle switch as well. Now let's run the thing. Okay, so as you can see, everything is in 0 position now. So now we are in idle position. Now if someone press the on switch, uses RB0 switch, will go on and press RB0. Now this thing should go on soft start. So it should go to, from state 0 it should go to state 1 if we run it. So we're going to run it now. As you can see, it went to state 1, which indicating is in soft start. Now if we keep on running the thing, it should go to servo forward. It should pick up the speed, which is state 2. Servo forward is state 2. As you can see, it went to state 2, which is servo forward. Now at this point, if you keep on running it, it should stay in state 2. Now at this point, if we increase and decrease the potentiometer, it should increase and decrease the speed respectively. Now we are in forward mode. Now if someone decided to go to reverse and flick the RB1, which is a transmission switch, so if we'll go on and flick RB1, now it's in reverse. Now we selected reverse mode, but we are in forward mode, but we don't want to go from forward to reverse directly. So we want to have some soft stop in our code, and we have done that in our code. And if you run it, you don't go to reverse mode directly, it will go to soft stop. So if you run it, as you can see, it went to state 3. Our state 3 is a void soft stop forward. Now if you keep on running, it should go to idle mode, which is 0. Now, as it happened for the forward, it should go to soft start reverse as well. Now it should go to soft start reverse is state 4, which is state 4 is here. Now same thing, it should go to servo reverse, and at this point servo reverse is to stay there. Now it depends on our potentiometer, it depends on how much you want the speed. Now same thing should happen if you flick it back to forward. It should go to soft stop reverse, and it should go to idle, which is 0. As you can see, it should go to soft start reverse forward, and then servo forward. Now at any point, now if someone decided to flick on RB0 back to off position, then it should go straight to off position. So if we'll go on and flick RB0, so it's in RB0 is 0 now. As you can see, RB0 is 0. Now it should go to state number 0, which is idle. As you can see, state number 0. Okay, so it will be there, continue forever. If I flick RB0 back again, it should soft start, which is 1. You go to servo forward. Now in our code we have some sort of overcurrent protection as well. So if overcurrent protection switch is on at any point, it should go to idle mode, and it should be there. It should be there permanently, because we don't want our go-kart or our motor to go any damage if overcurrent is on. So we'll go on and flick overcurrent switch RB3. At any point if this switch is pressed, it should go back to idle. Yep, as you can see, it's in idle now. Now if the overcurrent switch is on, as you can see in our code, with every condition we have used overcurrent condition RB3. With every single condition we have used AND. We have used an AND statement with other code. That let's examine this code, this part of the code. It says from idle mode to go to state number 1, RB1, which is transmission, should be in 0, which is forward, and RB0 should be in on position. We haven't fixed that to that one. We have included overcurrent protection as well. Now if our overcurrent switch, which is RB3, is 1, it won't go to state number 1. So as we have used AND condition with that, we have used to go to state number 1, our overcurrent switch needs to be 0, which is RB3 needs to be 0. Now our overcurrent switch is on, it will be there permanently. No matter if you change any other switches, it will be 0. It will not change state, it will not switch state until we change RB3 back to our overcurrent switch back to 0. If we're back to 0, we can see it's still in 0 because our on and off switch is in off position now. And now RB1 is in reverse mode. So if you press on RB on, you should go to soft start reverse, which is 4. Is it going to soft start reverse? You should go to servo reverse. So that's the part of our code simulation. And we've done code simulation is pretty much what we've done on the state machine, which is this one. So that was our simulation. I'll be signing off now. Thank you for watching.